The mystery of Venus. Today, I'd like to introduce you to the planet Venus, our neighbor in the solar system, named after the Roman goddess of beauty and love. Venus is the second planet closest to the Sun, yet intriguingly, it's the hottest of all 8 planets, even surpassing the temperatures of Mercury, which is closer to the Sun. Venus is a true hellscape. An image captured by the Venera 13 probe offers a glimpse of Venus's surface. The probe lasted only 127 minutes before its electronic systems were destroyed by the extreme heat. But what if I asked which planet is most similar to Earth in the solar system? What would your answer be? Feel free to share in the comments. Given that we're discussing Venus, this question might seem like a trick. However, many would intuitively answer Mars, as it's commonly associated with the search for water, life, or even the preservation of the human species on the red planet. Almost all manned missions being planned today are aimed at Mars, with some even suggesting the establishment of a colony there. It's unlikely anyone would think of Venus, a planet where sulfuric acid rains and temperatures can reach nearly 500 degrees Celsius. This stark contrast makes Venus an intriguing subject. On one hand, we have a planet with extreme and inhospitable conditions, yet on the other, it's the most similar to Earth in terms of size, composition, and proximity to the Sun. This prompts us to ponder the delicate balance of planetary systems and how minor differences can lead to drastically different worlds. Let's dive together into this mystery and uncover what more Venus has to teach us. Indeed, Venus is the planet most similar to Earth in terms of size, mass, density, and composition. There's evidence suggesting that Venus and Earth were formed around the same time and from the same ingredients, as both were located in the same region of the nebula that gave birth to the solar system. Venus, now nearly a hellish landscape, is considered Earth's twin planet. Some observations suggest they were quite similar from their formation and through the early stages of their existence. And in astronomy, when we talk about early years, we're usually referring to billions of years. Yet, something happened at a certain point that turned Venus into the veritable inferno it is today, while Earth continued on its path as the habitable planet we know. So, the question remains, how did Venus transform into this inferno? To answer that, we'll need to embark on a journey through space and time, back to around 4 billion years ago, when the solar system was a nebula of gas and dust. We still don't know exactly what happened, but something destabilized that cloud, causing regions of it to collapse under their own gravity. Some suggest that this something was a nearby supernova. Most of the material from that time, and we're talking about 99% of the mass, became the Sun, while the remaining 1% was divided among planets, asteroids, and natural satellites. However, our focus here is on the formation of the planets Venus and Earth. Being planets considerably close to the Sun, both Venus and Earth likely formed through the same process. A core emerging for the first time from the collapse of the gas and dust cloud, with material gradually being captured by this core through gravitational interaction. Given the proximity of their locations, it was to be expected that the composition of both during their formation would be similar. Indeed, both have an iron core, a mantle of magnesium silicate, and a silicate crust, characteristics that are not unique, considering that we have 2 other planets with similar characteristics that also formed in nearby regions. What really makes us pause and think is that Venus and Earth are very similar in size and mass. Venus is only about 5% smaller and less dense than Earth, which means they are nearly the same size, with similar masses and volumes. 2 planets formed almost together, with such similar traits, stand in stark contrast to Mercury and Mars, which are much smaller and less massive. And the similarities don't end there. The atmospheres of Venus and Earth were also quite similar initially, with a ratio of carbon dioxide to nitrogen of 97:3, making them basically two very similar spheres that were born almost at the same time and with the same composition. So, what happened to make Venus become this distinct hell from Earth? The answer dates back to the early days of the solar system, when the inner region was a true chaos. Asteroids, planetoids, and various objects came from all directions, attracted by the sun's gravitational field. Planets collided with planetoids, asteroids were drawn to the sun, or impacted planets constantly. This scenario turned the inner part of the solar system into an authentic battlefield, where only the most resilient survived. In this context, two significant events occurred. Firstly, it is believed that a small planet called Theia collided with Earth, and the result of this collision was the formation of the Moon. This impact altered the rotation period of the Earth, bringing it closer to what we know today. Additionally, the Moon played, and still plays, a fundamental role in stabilizing Earth's rotation. This is one of the reasons why the day has the duration it has. Secondly, Venus was also the target of impacts during that time, and one reason its rotation axis is opposite to that of Earth's might have been a significant impact. This event not only halted Venus's rotation but also reversed its direction. Yes, Venus spins in the opposite direction, and the likely cause was a collision. Imagine witnessing a cosmic event of such magnitude that makes a planet start spinning in the opposite direction. This significantly complicated Venus's situation. A day on Venus lasts 243 Earth days, and interestingly, a day on Venus is longer than a Venusian year, which lasts 224 Earth days. This means that New Year's celebration on Venus would actually mark the turning of a day. Unlike Earth, which has a natural satellite, the Moon, Venus has never had a natural satellite to call its own. Although this may seem trivial, it was one of the first differences to trigger a series of adverse events for Venus. The reason is that our Moon helps stabilize Earth's rotation axis. Venus, without this benefit, lacks seasons. Seasons are possible due to Earth's axial tilt, allowing different regions to receive varying amounts of sunlight at different times of the year. Furthermore, this means that the climate can remain stable for long periods. Venus, with an inclination of only 3 degrees compared to Earth's 23.5 degrees, does not experience seasons, resulting in its climate being nearly uniform everywhere, all the time. Venus's position in the solar system also did not favor its climate. Being the second closest planet to the Sun, it receives more sunlight than Earth. And considering the Sun in its adult phase would already be sufficient to have a catastrophic impact. When the Sun was younger, the situation was even worse because young stars are brighter and more energetic than older ones. Just like stars, any resemblance to your favorite rock star is not a coincidence. We can estimate that in its youth, Venus received 40% more sunlight than we receive here on Earth today. Venus's proximity to the Sun likely led to the evaporation of all the water that could have existed on the planet. Venus is not located in the habitable zone, and it's intriguing to note that it's precisely on the edge, but outside the habitable zone, while Earth is on the edge, but within the habitable zone. I'm starting to suspect that Venus is simply an unlucky planet. Interestingly, there are indications of water vapor and, notably, deuterium in Venus's atmosphere. This is relevant because when a water molecule is broken down into oxygen and hydrogen due to the sun's ultraviolet radiation, some of this hydrogen is deuterium, a heavy isotope of hydrogen. Deuterium hardly escapes the atmosphere, unlike oxygen, allowing us to estimate how much water existed on the planet based on these data. Recent simulations suggest that Venus could have had oceans for billions of years, possibly existing while life was already thriving on Earth. So, despite so many setbacks, Venus still showed potential. However, the challenges don't end there. One of them is the absence of tectonic plates on Venus, which may seem insignificant at first glance, but perhaps it was the final blow to the planet's fate. On Earth, tectonic plates play a crucial role in cycles like the water and carbon dioxide cycles, through a process where carbon is released into the atmosphere by geological activities, and then recycled back into the mantle thanks to these plates. This cycle was essential for regulating the greenhouse effect in Earth's past, maintaining enough warmth to preserve life. Moreover, tectonic plates are closely tied to Earth's geology, from volcanic activity to the formation of mountains, which are important for the climate. On Earth, internal pressure can be relieved in other ways through the edges of tectonic plates, meaning that volcanic activity isn't as intense as it could be. In Venus's case, the absence of tectonic plates prevents the carbon cycle, causing all the carbon dioxide to accumulate in the atmosphere. With no other ways to alleviate core pressure, volcanic activity remains the only outlet. Venus exhibits extremely intense volcanic activity, resulting in the constant release of large volumes of greenhouse gases into the atmosphere. To illustrate the magnitude of this difference, Venus's atmosphere contains about 96% carbon dioxide, while Earth has less than 0.04% in its atmosphere. Furthermore, the atmospheric pressure on Venus is 90 times higher than that on Earth, making its atmosphere so dense that it prevents the observation of the planet's surface in the visible spectrum. If someone were on the surface of Venus, they would be unable to see the stars due to the atmospheric density. This atmospheric density and composition contribute to temperatures on Venus being high enough to melt lead. And that's not to mention that volcanic activity is also responsible for the release of sulfur dioxide, which contributes to the formation of sulfuric acid clouds. Therefore, it's possible that there are sulfuric acid rains on Venus, a scenario that could be described as a true hell. So, faced with so much adversity, the question arises, why did Venus turn into this hell? The answer lies in a combination of geological, atmospheric, and proximity to the Sun factors that differ drastically from the geological and atmospheric development of Earth. The absence of tectonic plates and the extreme greenhouse effect, exacerbated by intense volcanic activity and the density of the Venusian atmosphere, played fundamental roles in this process, leading Venus down a very different path from our habitable planet. There isn't a single cause that alone is responsible for turning Venus into a hell. It was a series of events since its formation. However, if we had to choose the main culprit, it would certainly be the absence of tectonic plates. While on Earth, tectonic plates saved our planet from becoming a hell, their absence on Venus destroyed any possibility of life or a more hospitable environment. This absence may have been the decisive factor that shaped Venus into the inhospitable environment we observe today. But here comes the plot twist and the possibility of an existential crisis, the idea that Venus never had tectonic plates, or only had one large plate for much of its history, is widely accepted. However, this doesn't explain the amount of nitrogen present in Venus's atmosphere. It would be impossible to have such quantities without the existence of tectonic plates. Recently, astrophysicists published a study in the journal Nature showing that Venus possibly had tectonic plates in the past. This work suggests that only tectonic plates can explain the current Venusian atmosphere with the observed amount of nitrogen. And it doesn't stop there. Venus not only had tectonic plates but also may have been habitable and very similar to our planet between 2 or 3 billion years ago. This makes us rethink the habitability of planets as perhaps more temporary than we imagined. It also leads us to question, is Earth an exception, or will we face a future similar to Venus? This new knowledge could change our perspective on planets initially considered uninhabitable and on how we search for life in the universe. We still don't know what causes tectonic plates to cease to exist, for example, on Venus, turning the planet into a hell. This remains an open question in astronomy and planetary sciences. However, this answer raises new questions, such as whether we've been looking at this the wrong way all along and perhaps life is more common than we thought. Did Venus ever harbor life, and will that be the fate of our planet? I hope not, but the truth is we still have much to discover. Thank you very much for following along, and until next time. And don't forget to subscribe to the channel and leave your like.